Hello everyone, this is Mark, and today I'm going to be doing a tutorial on setting up the Raspberry Pi. So I've got my Raspberry Pi all set up. I've got a USB mouse and keyboard connected to it. I've got it connected to my capture card on my computer through HDMI. Generally you'd hook it up to TV or monitor, but it's much easier to record off of a capture card. So I have a USB cable connected, standing by. I'm doing this kind of against the official rules. I'm using a USB cable connected to my computer to power it. Ideally, you'd want a dedicated power supply, but I can't find mine right now, so this is what I'm using. And you also need to have an SD card. The one I have, I believe, is an 8 gig SD card. Let's take a look here. Where is she? Right here. Yeah, we can't tell through that. I've already recorded an image to it because of my previous video on Minecraft Pi. So, I'm pretty sure it's 8 gig. I'm not going to pull it out to look at it. It's not that important. I think you need 2 gig is the minimum. Let's take a look at the image. Yeah, 2 gig minimum. The image is 1.8 gigs. And there's my cat whining. And he's coming to visit me. How cute. Just ignore the whimpering. So what we're going to do today is I'm going to show you how to record this image to the SD card, and I'm going to also configure it up on screen and get it into a graphical user interface so that we can begin using it. The whole point of this is I'm going to try to do a kind of a step-by-step from the initial setup, which is going to be this video, up into programming using Minecraft Pi. My previous video on just taking a look at Minecraft Pi was very popular, so I figured we'd go from there. Start from scratch. So what we've got here is you need this Win32 disk imager, which I will put a link to in the description. There is also a link on the Raspberry Pi website. You need the Wheezy Raspberry, which I will also put a link to. This is the official operating system image for the Raspberry Pi. I think there's 4 or 5 different ones on the Raspberry Pi website. There's a whole bunch more out there. I've only played with 3. I've played with the Raspberry, I've played with the Raspberry with the soft integer, which allows for Java, which I may do a video on, and the, what was it? It was the Media Center one. I can't remember what it was. That was a while ago. That was when I first got the Pi. This Pi is one of the release ones. I got it shortly after it was officially released. I was probably one of the last ones of the back-ordered ones to get it. But enough of that. Let's get into it. So I've got the disk imager all set up here, and I've got it pointed to that Raspberry image, which is in there. I've got it set up for my G drive. So it's just going to destroy everything that's on that G drive. Anything you had, if you had images on it, you want to back it up, make sure this is not a card that you're going to be using for anything else. This is going to be taken over completely by the Raspberry. So we'll hit right. It's going to confirm, you know, if you do it wrong. Basically, if you try to write an image improperly, There's certain images out there that can potentially corrupt the SD card. I've never seen it happen, but I know that it can happen. This is just confirming. Whatever raw image writer you have, unless you're using Linux's DD, will always confirm. So we just hit yes, and then we wait for the long process to write it to the card. This is purely dependent on the speed of the card and the card reader. Everything else is pretty much trivial. So what I'm going to do is I will speed this up so you can see the whole process. I'm not going to cut any of it out, just so you can see it. It does take quite some time. Alright, so as you can see, it didn't go too fast. It was only 5.5 meg per second. It took almost 7 minutes to do, but we are done. We now have the image on the SD card. And apparently it did not remount it. There it is. So there's our SD card in all its wonderful glory. So I still have two things that I want to do with it. Let's go back here and grab my Minecraft Pi, which I've extracted from this tarball here. Normally I would just copy the tarball over and extract it on the Pi, but I already have it extracted here because I was looking at the API documents. So let's copy this over. We will expand that. Not too bad. It's only little. Alright, and the last thing that I want to do is I want to edit this config.txt, because the last video I had, it was 1080, and in order to see anything you had to watch it in 1080, and that wasn't cool. So I'm going to make it 720. That'll make the text a bit bigger, should work better for the recording. At least I hope. I haven't actually tested it yet. I'm going to disable this overscan, but I'm actually going to do it within the setup itself. So we'll save that, close that, let's get out of there, and I will safely remove that. I'm a stickler for the safely remove hardware, especially when dealing with disk images. You want to make sure that it's written to the disk. Some people just don't care, and there's always that possibility that, or there's a good chance that nothing's going to go wrong. But better safe than sorry. So I'm just sliding it into my Raspberry Pi. And I'm going to switch over to my tuner card. So you're just going to get a black screen there. And I am plugging in the USB power. And it's out of range. Won't be for long. Hopefully. It's saying it's working. Alright, so I guess I got some troubleshooting to do. It looks like it's booting, but this is just not showing on the screen. So I'm going to actually stop the recording right now, figure out what is going wrong. Alright, and I have no idea what happened there. The program that I was using to record with apparently couldn't get the image properly. But the actual program for the capture card works fine. So here it is. This is the initial boot. I haven't rebooted it or anything. So this is what it boots into. It always starts up with the Raspi config the first time. So what I'm going to do is I want to expand the root FS. Basically, what this will do is it'll resize the main drive for the Raspberry Pi to fill the entire SD card. As I showed before, the image was only 2 gig. So depending on the size of the card, like I've got an 8 gig, it's going to expand that from the 2 gig to 8 gig to fill the card so I don't have a whole bunch of wasted space. So right now, I'm not sure if it'll come out in the recording, but I have probably about 1/2 inch border around the screen. So that's the overscan. So I can't stand that. So I'm going to disable the overscan. And for some reason, the keyboard layout is all wonky. Everything's set to Britain. So it's all British layouts. I think it's British time zone. So I have a 104 key, and English UK is not what I have. I would be English US, and just a basic English US keyboard. I'm just going to leave the default for this keyboard layout and no compose key. I like this feature. So if the X Windows system just locks up on you completely, if you hold Control, Alt, and Backspace, it will just kill the process and restart it. So I like that if I'm working in a graphical interface. So basically what this allows is some of the special keys. I think I use pipe a lot. I think that was some odd key. I like to use the tilde key because that brings me home. And that was another weird key. So it was just, I just have to go to the set keyboard layout. So set my locale. So again, unless you're in Britain, you'll probably want to do this. And there we go. Great Britain. So we want to go English US. Or no, UTF-8. That's not English. That's not what I wanted. That, I believe, is Spanish. Yeah, this could mess me up. All right, let's try that again. This time, let's do English. The infinite list. And there's my furnace kicking on. English US. Yeah, I went right past it. So there we go. English US. Choose the language for your own locale. So I'm setting that as my default language. That's really all that is. Let's change the time zone. And we would be in the Americas, and closest place I am is Toronto. Good old Southern Ontario. Alright, now to the important stuff. So this memory split. So mine has 256 megs of RAM, and it has to share that between the system RAM and the video card. Default looks like 64. What I'm going to do is I'm going to do 128. So I'm going to do a 50-50 split. And I'm hoping that that gives me a good bit for each side. This overclocking, as it says, be wary of it. Just like overclocking your main computer, overclocking this does have some potential pitfalls. So your default is 700 megahertz with a 250 megahertz core and a 400 megahertz RAM. So I tend to avoid the overvoltages. Like once you start overvolting things, you start asking for problems. Especially since this guy is designed to take 5 volts. If you're 6 volt overvolting, that just seems a little excessive to me. So I tend to stick with the 800. I did actually run it for a little bit at the turbo, and I think that's what caused, because I had an SD card corruption and I had to completely wipe it again. And if you actually choose this one, we'll do that one. Some people report SD card corruption with this level. So it's entirely possible. Let's go back in there. This doesn't take effect immediately. You have to reboot to have it take effect, because these are all settings that are done in that config.txt, I believe. So I tend to stick with the 800. It's just a slight overclock. To be honest, for what I've done, I've noticed no difference between the 700 and the gigahertz. And I am being called, and we're going to ignore that. So, SSH, if you want to use it as like a mini web server or something, you would probably want to enable that because you're not going to have it connected to a monitor at all times. That's not important to us because we're going to be running it directly through the desktop. So now we want the boot behavior. This is what I care about right now. Should we boot into the desktop? This is the graphical desktop as opposed to a command line. Anyone who's familiar with Linux will know what this is. Anyone who's not familiar with Linux might not know what this is. It's kind of like the DOS command prompt from yesteryears, or in current versions of Windows, it's just the command prompt. But it's the full thing. Like, there's no graphical interface, no mouse. So what we want to go to desktop. So we want that graphical interface because Minecraft requires that. So we'll say yes to that. And that'll set all of that. Under normal circumstances, if I had the network connected, I would do an update, and that would make sure that this config script is always updated. If you ever want to run this again, all you need to do is type that raspi config, as it is there, raspi-config, at the command prompt as root. But I can't do that because I don't have a network connection. So I'm just going to hit finish. It's going to ask us to reboot. I'm going to say yes. And let's watch it reboot. It is not the fastest. I will say that a lot. And there it goes, shutting down. For the most part, you don't need to worry what all of this is. This is what pretty much every operating system will do. The only difference is Linux actually tells you what it's doing. Whereas Windows, it doesn't spit it out. You can get a lot of this information from Windows. Not all of it, but you can get a lot of it. It's just a little different. So now we're actually booting up. So this is all the hardware we have. Little Raspberry logo in the corner. Setting up the swap. Again, all stuff that isn't really necessary to know. But it doesn't hurt to know it. Right now, it's doing the one-time resizing, so it's actually changing the amount of space that it thinks it has from the 2 gigs up to the 8 gigs. So that's done. Oh yeah, and that brings me to a point. If you do overclock, you do something that the Raspberry Pi just does not like, you can actually hold Shift while booting, and it will actually disregard all those changes. I'm not sure how far it does, but it does. Alright, so here we are. We are at the desktop. Have our mouse, we have Midori, Scratch, the Pi Store, Wi-Fi config. I don't have any Wi-Fi set up on this, so we can ignore that. The Pi Store, who cares? Debian reference. This is good if you don't know anything about Linux or Debian. Debian is just a distribution of Linux. It's a style, it's a flavor. So that's handy. I think that requires a network connection. So I'm not even going to bother. And the main things that we're going to work with is this LX terminal. So this is your command prompt. And idle. So sometimes it doesn't take my mouse clicks properly. There we go. Alright. So, last thing I'm going to do is, as you can see, we don't have that Minecraft Pi. If you watched my last video, you probably know where it is right now, but it is actually in the root boot. So to get there, you do that. You have to go back to the root, which is just a slash, and then you go boot. And now if we go in here, those are all the files that were listed on the drive when we saw it in Windows. This is actually a separate partition. This is a partition that Windows can read, whereas if we go to root, this is everything that's there. This is what was expanded. This is what takes up the majority of the space. If I do a DF, which is, it stands for disk free is how I remember it. This tells us what's there, essentially, what's mounted. For the most part, you can ignore dev, you can ignore tempfs. Those are just RAM disks, which is just a fancy way of saying part of your system's memory being utilized as a virtual disk space. What we want is, well, I guess dev root or rootfs, those are exactly the same thing. Those are just different ways of pointing to the same location. And then the /dev/mmcblk op1, or actually it's 0p1. That's the actual SD card. It's only 55 megs. And that's boot. So that's what Windows can see. That's standard Windows file system. Whereas the root FS is a Linux-only file system. You need special utilities to read it in Windows. And to be honest, I haven't found one that actually works properly with the SD card. But I've only tried 2. And for the most part, they don't work in Windows 7. So let's go back to boot. So again, we can ignore everything. All we care about is that MCPy. So I'm actually going to move MCPy to root. Except I can't, because I don't have permission to write to root. So I have to go as super user, and then I can move it. So MV is move. There is no rename. If I wanted to rename it, all I would do is just do that and move it to a different name. But what I want to do is that. So that will just move it from boot, where as soon as it loads, there we go. It's gone. If we go back here, we have MCPy. But now here's an issue. If we do a long listing, which is what the ls-l, ls and dir, if you're familiar with DOS command line, dir is a directory listing. ls is pretty much the same thing, but it's the Unix equivalent. ls-l tells it to do a long listing, which gives you the permissions, it gives you who owns it. And as you can see, everything in here is root. So the user is root, the group is root. We want MCPy to be able to be accessed by the Pi user. So we're going to do a chown, which is a change owner, pi dash capital R for recursive. I should actually have that capital R before the pi. I don't think it really matters. I think I actually did it before and it doesn't matter. So basically what this will do is it'll change the owner recursively. So every folder, every file under MCPy will turn to being owned by the user Pi and the group Pi. So we do that, and we can't do it because we're not the owner of it. So we have to do a sudo, which elevates us to a super user. And now we did it. Do that again, and now we'll see pi. So now we can pretty much do whatever we want with this MCPy. And Minecraft Pi is executable, so we just do that. The / is required, because unlike Windows and DOS, it does not check the current directory, it only checks the path. So you have to give it a explicit name. So / is in this directory, that file needs to be executed. So we hit Minecraft Pi, and we have Minecraft. So, I'm not going to create a new world, because that is something for another day. I think I've bored you guys enough, giving you a quick look at the Raspberry Pi, how to set it up. Feel free to leave comments, correct me where I'm wrong. Although, I don't think I'm too wrong on anything. But we'll find out. There's a lot of people out there that are better than this at me. Hopefully they like it. Definitely like, comment, subscribe. Let me know what you want to see. Next video, I'm planning to do a little bit on the Minecraft Pi API. This was just a brief on how to get to that point. All right. So thank you all for watching. You guys have a great day. Take care.